Hi all, today's topic is 3D translations. 3D transformations take place in a three-dimensional plane. That is, if an object is represented using three coordinates x, y, z, then we can say the object is a 3D object. So, coming to transformations, in computer graphics, various transformation techniques are available, such as translation, rotation, scaling, reflection, shear. So coming to 3D translations, moving an object from one point to another point is called translation. So consider a point object O has to be moved from one position to another in a 3D plane. So, let initial coordinates of the object O is x alt, y alt, z alt. The new coordinates of the object O after translation will be x new, y new, x alt. The translation vector of shift is tx, ty, tz. Given a translation vector tx, ty, tz, tx defines the distance from the old point to the new point, x point, the old x point to the new x point. Then ty defines the distance from y old to y new points. Then tz defines the distance from x old to x new. So here is a graphical representation. Here is a point O which have coordinates x alt, y alt, z alt, and we are moving that object from O to O dash. The coordinates of O dash is x new, y new, z new. So this is called a translation, moving an object from one point to another point. This translation is achieved by adding the translation coordinates to the old coordinates of the object. That is, we can get the x new, y new, z new coordinates by adding the translation vectors with the old coordinates, that is x alt, y alt, z alt. So here is the equations. We can obtain x new by adding x alt plus tx. Tx is the translation vector of x coordinate, and we can get the new y coordinates, y new, by adding y alt plus ty. Then we can get z new by adding the points, by adding the vector with the x alt coordinate. And this is the representation of 3D transformation in matrix. So coming to the next translation, that is 3D rotation. Rotating an object from one angle to another is called rotation. So consider a point object O has to be rotated from one angle to another in a 3D plane. Let The initial coordinates of the object will be x alt, y alt, z alt. And the initial angle will be represented using phi. Then rotation angle, that is the angle to be rotated, is represented using theta, and the new coordinates is represented using x nu, y nu, z nu. So in 3D dimension there are three possible types of rotation: x-axis rotation, y-axis rotation, z-axis rotation. So coming to x-axis rotation, the rotation happens in x-axis. This rotation is achieved by using the following rotation equations. So in x-axis rotation, we know that the rotation happens in x-axis. So the x coordinate will be same, that is x nu equal to x alt. Then we can find the new y coordinate by the equation y nu equal to y alt into cos theta minus z alt into sin theta. And we can find z nu by using the equation z nu equal to y alt into sin theta plus z alt into cos theta. And we can represent x-axis rotation as matrix also, that is shown in the picture. Then coming to y-axis rotation, the rotation happens in y-axis. So here the y coordinate will be same. There is no change in y coordinate. Now we can find the another new coordinates x nu and z nu. The equation for that is x nu equal to z alt into sin theta plus x alt into cos theta. And we can find z coordinate, the new z coordinate z nu equal to y alt into cos theta minus x alt into sin theta. And we can represent the y axis rotation in matrix also, that is shown in the picture, as shown in the picture. Then coming to z-axis rotation, the rotation happens in z-axis. So this z coordinate is same, will be same. So z nu equal to z alt. Then x nu, the new x coordinate is found using the equation x nu equal to x alt into cos theta minus y alt into sin theta, and y nu equal to x alt into sin theta plus y alt into cos theta. So that's all about rotation. So coming to the next translation, 3D scaling. The process of increasing or decreasing size of an object is scaling. To do scaling, we consider a factor that is called scaling factor. If the scaling factor is greater than 1, then the object size is increased. If the scaling factor is less than 1, then the object size is reduced. Now, consider a point object O has to be scaled in 3D plane. So, let the initial coordinates of the object O will be x old, y old, z old. Then the scaling factor for x-axis is sz. The scaling factor for y-axis is sy, and the scaling factor for z-axis is sz. And the new coordinates of the object O is represented as x nu, y nu, z nu. So how can we achieve the new coordinates? We can achieve the new coordinates by multiplying the old coordinates with the scaling factor. So we can find x nu using the equation x nu equal to x old into sx, y nu equal to y old into sy, z nu equal to z old into sz, and we can represent scaling using matrix also. This picture represent 3D scaling matrix. So the next transformation is 3D reflection. Reflection is a kind of rotation where the angle of rotation is 180 degree. The reflected object is always formed on the other side of a mirror. That is, we can say reflection is a kind of rotation. But the difference is the angle of rotation will be always 180 degree. If the reflection of an object is equal to the mirror image of the object, the size of reflected object is same as the size of original object. There will be no change in size. And reflection is of three types: reflection relative to xy plane, reflection relative to yz plane, and reflection relative to xz plane. So, consider the initial coordinates as x old, y old, z old, and the new reflected object's coordinate will be x nu, y nu, z nu. Then, how can we express reflection relative to xy plane? The reflection relative to xy plane, there will be no change in xy coordinates. That is, the x nu and the y nu is equal to the x old and y old. There is no change in x and y coordinates. And the next coordinate, that is the z coordinates, the z nu equal to minus of z old. That is the difference. And we can represent it's in matrix form. So this picture shows how we can represent reflection of xy plane. Then coming to next, reflection related to yz plane. So we can say that reflection is related to yz, then there will be no change in the yz coordinates. That is, y nu equal to y old and z nu equal to z old. So there will be a difference in x coordinate. X new will be minus of x old. Then coming to the third reflection relative to xz plane. So we know that there is no change in the coordinates of x and z. That is x new equal to x old and y new equal to z new equal to z old. But there is a change in y new coordinates, that is y new equal to minus of y old. So that's about reflection. So coming to the last translation, that is 3D shearing. A transformation that slants the shape of an object is called shear. So, in a three-dimensional plane, the object size can be changed along x direction, y direction as well as z direction. Then it is called shearing. So for example, this picture represents shear. So the original picture object is P and the P dash object is sheared object. So this is an example of shear. Then versions of shearing. There are types of shearing. Shearing in x-axis, shearing in y-axis and shearing in z-axis. So considering an object with the initial coordinates x old, y old, z old and a shearing parameter towards x direction equal to shz. The parameter towards y direction is denoted by shy and the parameter towards z direction is shz. Then the new coordinates, that is x new, y new, z new, is calculated by the following equations. When the shearing is in x-axis, that is the x new coordinate will be same as the x old coordinate. There is no change in x coordinate values. The change happens in y coordinates and z coordinates. So y new equal to y old plus shy into x old. That is y new equal to the old coordinates of y plus the shearing parameter of y into the old value of x coordinate. Then coming to z coordinate, z new equal to z old plus shz into x old. The old coordinate is added with the multiplied value of x old and the shearing parameter towards z direction. Then going to shearing in y-axis. Here the y coordinate will be same. There is no change in y coordinates. Change happens in x and z coordinates. So we can calculate x new as x old plus the shearing parameter towards x-axis into y-old coordinates. That is, the x-old coordinate is added with the multiplied value of y-old and the shearing parameter of x. And we can also get z nu using the equation z nu equal to z old plus shz into y old. Here shz is the shearing parameter towards z. Then we can represent it as matrix form as in the picture. Then coming to shearing in z axis, here there is no change in the z coordinate, that is z nu equal to z old, and we can get x nu using the equation x nu equal to x old plus shx, that is shearing parameter towards x axis into x old coordinate, as well as we can get y nu equal to y old plus shy into z old. And this is how we can represent shearing in x-axis as matrix. This picture represents the matrix representation. So that's all about 3D translations. Thank you.